Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 1980. Find unique binary strings. It's medium mark. Let's read the question. Given an array of strings nums containing n unique binary strings, each of length is n. Return binary string of length n that does not appear in the nums. If there are multiple answers, so you may return any of them. Let's see the constraints. Nums dot length is n and n can be up to 16 only, and nums of i's length is n, so it is also n. So nums of a contains either 0 or 1 because it is a binary string. All the strings of nums are unique. Okay, so let's see what they are saying. So we have a nums array of length n and each string in this nums array is also length of n. Got it? Okay, and these are unique, so we will not be having a duplicate strings. Okay, now let's take with an example. So in this example they have given 0 0 and 0 1. So here what is the length of the array? N is equals to 2. And what is the length of the string in this array? It is also 2. So length of the string in each string in the list is also 2. So if we know that how many binary strings are possible of length 2. So if we take, that is 2 to the power of n binary strings can be possible of length n. So in this scenario 2 to the power of 2, which is 4. So total 4 binary strings can be possible of length 2. So what are those binary strings? 0 0 0 1 1 0 1 1. So these are the binary strings possible of length 2. If we observe, 0 0 is present, 0 1 is also present, but 1 0 is not there. So we can directly return 1 0 for this question. Got it? Now let's see this one. So here they have mentioned 111 011 001. So these are the given binary strings of length 3 and only 3 elements are present. So how many total possible binary strings can be possible of length 3, which is 2 to the power of 3. So 8 binary strings is possible of length 3. So in the list they have given only 3. So 5 binary strings are missing of length 3. So what are those? 001 010 011 100 101 110 1. So if you see 0 0 is present in this list, so no, it is not present. So we can directly return here 0 0 0. So result is 0 0 0. So that's how we can find the solution. Okay, now let's see how let's take an approach. Let's see a brute force approach. So what I did currently, so I know that I am going to get 2 to the power of n binary strings for the given any length n, right? So what I will do is I will iterate from 0 to n minus 1 times, and I will check is this I is present in my set or not. So what I will do is first I will convert that given list into a set. So for in this scenario I will take this 1 1 0 1 1 and 0 0 1 into a list. Okay, I will take this into a list, and then I will iterate from 0 to 2 to the power of n minus 1. And what I am doing, each time I will convert this into a binary string. So I will convert this integer into a binary string. So using integer dot to binary string. So I will pass this, and it will give me the binary string. So I will check is this binary string is present in the set or not. If it is present, then we don't need to do anything. If it is not present, that means we need to return that answer. Got it? So that's how we can simply check. Now let's write pseudocode for this one. So what do we need to do? We need to iterate for int I is equals to 0, I should be less than 2 to the power of n minus 1 and then I plus plus. Okay, and we need to convert this into a binary string. Int b is equals to integer dot to binary string. I need to pass this I. So either we can write our own method also. So for now let's use the inbuilt method, and now we need to check is this b present or not. If it is not present, if set dot contains this binary string, right? If it is not contains, then we can directly return the I. Okay, if it is present, then we don't need to do, we will check for the remaining numbers. So it is guaranteed that, right? It is guaranteed. So only n numbers are present out of 2 to the power of n. So there are 2 to the power of n minus n numbers are missing from the list. So it is guaranteed that we will definitely find the answer. Okay, now let's see the time complexity for this one. So here we are iterating 0 to 2 to the power of n minus 1 times, that is 2 to the power of n times, and here we are converting into a binary string. If you write your own method, that will take log n times, right? To convert a decimal number into a binary number, it will take log n of time, and we are using a set of length n. Okay, so what is the total time complexity? Total time complexity will be big of 2 to the power of n cross log n. And what is the space complexity? Space complexity is we are using a set of length n, so it will be big of n. Got it? So let's see how we can optimize this solution. Okay, let's see the optimal solution. Okay, let's see the optimal solution. Optimal solution is we have a algorithm called Cantor's diagonal arguments. So what this algorithm says that, so if you choose the ith character from the ith string, see, if we choose the ith character from the ith string and flip that character, it will give us a new string. So what does that mean is, so let's take one example. We have 111 011 001. So we have 0 111 011 and 001. So if we choose the ith character from the ith string, so this is the 0 1 2, so these are the indexes, and if you choose the ith character in the ith string, so if you choose the 0th index from this one, and one index from this string, and second index from this string, so if you choose these ith characters from the ith string, and if you convert, if we flip them, so 0 0 0, so it will give us a new string. So what is the new string? 0 0 0 is our new string. So is this new string is present in this list? No, it is not present, right? So that is the Cantor's diagonal arguments. So it says if we choose the ith character from the ith string, it will give us a new string. So what does that mean? So let's take one this one 1 0 1 1 0 0 1. So we are choosing the diagonal elements, right? We are choosing the diagonal elements. So this is the 0th row, first row, second row, 0th column, first column, second column. So if you choose ith character from the ith row, and ith character from the first row, and ith character from the second row, so 0 0 1 1 2 2, if we choose these diagonal characters and we flip them, it will guarantees that it will give us a new string, right? So what is the guarantee? How we can ensure that? Let's verify that also. So we have 1 1 1. What is our new string? 0 0 0. So this is our 0th string, right? If we observe its 0th character, it is not matching because we flipped it. So it is guaranteed that it will be not matching with the 0th string. Okay, now let's check with the second string 0 1 1. If we compare it with the new string, this is the first first string, right, which is present in the first index. So if we observe the first index in the string, it is also not matching because we flipped that character. So the first index is also not matching. Let's compare it with the next string 0 0 1, and if we compare it with 0 0 0, so the second index is not also matching for the second string. So second index is also not matching because we exactly flipped those ith characters every time for the all the strings. So it is guaranteed that our new string will be definitely not matching with the ith character with the ith string. Got it? So in this for the zeroth string, zeroth character is not matching. For the first index string, with the first character is not matching. For the second index string, second character is not matching. So it is guaranteed that it will not match with the any string that is present in the list. Got it? So we will directly return the answer 0 0 0. Okay, now let's do the pseudocode for this one. So what we need to do, we need to iterate the list. For int I is equals to 0 to I should be less than n, which is length of the string, sorry, length of the list, and then I plus plus, and then we will need to take the ith character from the ith string. So I will take char ch is equals to what is the array, right, arr dot arr of I dot char at of I. Got it? Ith character from the ith string. So I will be choosing the ith character from the ith string, and what I will do, I need to flip this character. So that means if ch is double equals to 0, then I will choose. So let's take a string builder here. Sb is equals to new string builder. So if ch is equals to 0, then I will append 1. Sb dot append 1. In else scenario, I will append 0. If it is 1, I will append 0. If it is 0, I will append the 1. Got it? And at the end, we will simply need to return sb dot to string. Got it? So now let's see what is the time complexity for this one. We are iterating only list one time 0 to n. So 0 to n. So it would be big of n. And what is the space complexity? Space complexity is, we are not using any extra space, so it would be big of 1 only. Got it? Now let's try to write code for this. Let's take int n is equals to nums dot length, and then let's take a string builder. Sb is equals to new string builder. Now let's iterate the nums list. Int I is equals to 0 to I should be less than n, I plus plus. So we need to get ith character from the ith string. So I will be doing char ch is equals to nums of I dot caret of I. So ith character from the ith string I will be getting, then I will be flipping the character. If ch is double equals to 0, then I will append sp dot append 1. So if it is 0, I will append 1. If it is 1, then I will append 0. So in else condition, I will append 0. Got it? That's it. And at the end, we just need to return sb dot to string. Got it? That's it. Now let's try to run this code. Yeah, it is accepted. Now let's try to submit this code. Yeah, it is accepted with 0 milliseconds runtime. If you like my content, do like, share and subscribe. Thank you.